Hey girls, we're back and we are talking about multiplying and dividing complex numbers. So let's do this multiplication problem first. It's a word problem, but it ends up being multiplying complex numbers. So let's read it and find out how to set it up. It says, in an AC circuit, the voltage V, current C, and impedance I are related by the formula V equals C times I. Find the voltage in a circuit with current 2 plus 4J amps and the impedance 9 minus 3J ohms. And as a note, it says electrical engineers use J for the imaginary unit to avoid confusion with the I that they use for the current. So if we're trying to set this up, we know we need to plug in 2 plus 4J for the current C, and we need to plug in 9 minus 3J for the impedance I. So it's going to look like this. V equals 2 plus 4J multiplied by 9 minus 3J. Now, if you're multiplying binomials, we know that we have to start by distributing the first term in the first parentheses. So we're going to distribute that to both terms over here. It works the same as it does when you have a variable. So 2 times 9 makes 18. 2 times negative 3J makes negative 6J. And then you're going to do the same thing, but you're going to distribute your positive 4J to both terms over here. So you get positive 36J and negative 12J squared. You have a couple like terms here, negative 6J, positive 36J. Those can combine together to make positive 30J. And then also in this step, I'm going to go ahead and substitute out J squared because I know that the imaginary number squared is always equal to negative 1. So whenever I'm simplifying and I see an I squared, or the imaginary unit, in this case they're using J, squared, I know I have to replace it with negative 1. Now this isn't totally simplified yet because negative 12 times negative 1 makes positive 12. Oops. And now I have some more like terms, 18 and 12 combined together to make 30. So I have 30 plus 30J as my final answer. It didn't give me a unit on this, so I'm going to go ahead and just leave it as the voltage is equal to 30 plus 30J. Now that's important to understand when we go to get to dividing complex numbers, because we have to know how to distribute these. Let's take a look at some examples together. For example, if we wanted to simplify 2I over 3 plus 6I, we have to change that because we know I is equal to the square root of negative 1. In Algebra 1, we learned that you're not allowed to have a square root in a denominator. So we have to multiply this by something to get rid of the square root in the denominator. Anytime you're trying to get rid of a square root in the denominator, you multiply by something called the conjugate. The conjugate means that you have the exact same two terms, 3 and 6I, but you change the sign in between to be the opposite. So instead of plus, you change it to minus. That's called the conjugate. By multiplying by the conjugate, you'll notice that we're going to end up getting rid of that I in the denominator. But you're not allowed to only multiply by something in the denominator. You have to multiply by the same thing in the numerator to keep it balanced out. So let's take a look. When we multiply 2I by 3 and negative 6I, we have to distribute, so we get 6I minus 12I squared on the top. On the bottom, we have to distribute two terms. We're going to distribute our 3 first, 3 times 3, and 3 times negative 6I, so that's 9 minus 18I. And then we distribute our other term, our positive 6I. When we distribute the positive 6I, we get positive 18I and negative 36I squared. Now, the reason why it's important to use the conjugate is because that way you'll always end up with opposite terms in the middle. Negative 18i and positive 18i cancel each other out. It makes 0. So that's always going to happen by using the conjugate, is the I will always cancel out on the bottom. So we have 6i minus 12 times I squared, but we know I squared is negative 1, over 9 minus 36i squared, but again, I squared is equal to negative 1. So on both the top and the bottom, the numerator and the denominator, I'm subbing out I squared for negative 1. Replace I squared with negative 1. I squared is equal to negative 1, so you should always replace I squared with negative 1. Now to simplify, we have 6i plus 12, because a negative times a negative makes a positive. And on the bottom, we have 9 plus 36. Combined together, 9 plus 36 makes 45. So we have 6i plus 12 over 45. In the instructions, it said our answer should be in that standard form, a plus bi. That's called standard form. So we're going to have to rearrange this a little bit and split it up. So not only is our I term supposed to come second, it should say 12 plus 6i, but also instead of putting it all over 45, we're going to actually split this up. So we're going to do 12 over 45 plus 6 over 45i. You're going to leave the I second, kind of like how when you're doing, what's that called? Slope-intercept form. Sorry, I blanked for a second. If you're doing slope-intercept form, like y equals 1/2 x plus 3/2 or something, you put the 1/2 in front of the x. Same thing here, you're going to put the 6 over 45 in front of the I. Okay, now you check, can either of those reduce? 12 and 45, those definitely share a common factor. 6 and 45, those definitely share a common factor. So let's reduce. 12 and 45 could reduce by 3 for sure. 12 divided by 3 is 4. 45 divided by 3 is 15. 6 and 45 also share a common factor of 3. 6 divided by 3 is 2. Again, 45 divided by 3 is 15. So our final answer in simplified form is 4 over 15 plus 2 over 15i. Hopefully I didn't mess up any math there. That should be correct. And we'll do one more where we have 4 plus I over 5i. This one's actually a little easier because there's only one term in the bottom instead of 2. So if there's only one term in the denominator, you don't have to multiply by the conjugate because there is no such thing as a conjugate. Remember, a conjugate's when you change the sign in the middle between the two terms. But if there's not even two terms, there's only one term, all you have to do is you have to just multiply by the same thing on the top and the bottom, by 5i over 5i. Remember, we can't have a square root in the denominator, and I stands for the square root of negative 1. So think back to Algebra 1. If you had something like 2 over the square root of 3, and you wanted to simplify that, you have to rationalize the denominator by multiplying by the same thing that you see in the denominator. You multiply that number on the bottom and on the top. That way, it gets rid of the square root on the bottom, because that cancels out, leaving you with just 3. But in this case, let's go back. We're just going to multiply by the same radical. And even to make this a little simpler, you could even just look at the I. You don't even have to use the 5 here. You can just do, if there's just one term, multiply by I over I. On top, we have to distribute. I has to distribute to the 4 and the I. So we get 4i plus I squared on top. On the bottom, 5i times I makes 5i squared. Just like the last problem, anywhere you see I squared, you replaced it with negative 1. So it's 4i plus negative 1 over 5 times negative 1. You just replace it with negative 1. You don't change the plus sign or anything yet. But now when we see plus and negative, you can replace that with 4i minus 1 over, on the bottom, 5 times negative 1 is negative 5. Remember, we want it to be in the standard form a plus bi. So we're going to switch these two terms around, negative 1 plus 4i. And then it's all over negative 5, but we want to split it up. So it's negative 1 over negative 5 plus 4 over negative 5 with the I next to it. We still have to simplify this a little more. 1 over 5, they're both negative, so they cancel out the negatives, just giving us positive 1 over 5. And for the second term, it's a positive over a negative. That makes a negative, so instead of putting plus, I'm going to put minus 4 over 5i. If you had done 5i over 5i, you would eventually get the same answer. You would have just had to simplify it later on. If you did try those practice problems, here are the correct answers for them. On both of them, they had two terms on the denominator, so you had to use the conjugate, meaning you have to change the sign in the middle. The terms stay the same, you're just changing the sign in the middle. That way, it'll cancel out the i's on the denominator. And same as before, wherever you see I squared, you replace it with negative 1 and split it up so that it's in the right order, a plus bi. Those are your final answers. Let me know if you guys have any questions, and I hope you have a great rest of your day. Bye, girls.